This question comes from 3.5, and it says manufacturer produces 2 models of desks. Model A requires 3 hours to stain and finish and 2 hours to assemble. Model B requires 4 hours to stain and finish and 1 hour to assemble. The total amount of time available for staining and finish is 21 hours, and for assembly is 12 hours. Let X represent the number of Model A desks produced, and let Y represent the number of Model B desks produced. So it says to write 2 inequalities that express the fact the number of desks to be produced cannot be negative. 2 inequalities, so let's fill in the blanks here. So for the Model A desk, we're going to put X, and then we're going to select the greater than or equal to. So that if they can't be negative, then they have to be positive or greater than or equal to 0. So positive or 0. So we want to say greater than or equal to for both of them. So let's hit check answer, and we get a green check mark. So now for part 2, we are going to write an inequality in terms of the number of Model A and Model B desks that can be produced if the total time for staining and finishing is at most 21 hours. So we have to, at most is this less than or equal to inequality. So the word at most means it can be that number or less than. So we're going to say 21 on that right side. And then on the left side, it takes, and this is for staining and finishing. Let's go back up to the question and let's read. So stain and finishing, 3 hours for Model A, and for Model B it's 4 hours. So we're going to put 3x plus 4y. X represents the number of Model A desks and that are produced, and Y represents the number of Model B desks. So let's check our answer there and see if we got it correct. We did. So now we have part 3. And so now it says write an inequality in terms of the Model A and B desks that can be produced if the total time for assembly is no more than 12 hours. So again, when I click here, no more than is the less than or equal to sign. So we're going to put 12 here on the right side. And then let's go back up here. Model A is 2 hours to assemble. Model B is 1 hour. So I'm going to put 2x and then 1y, but I don't have to type the 1. And then I'm going to hit check answer. I got that correct also. So now I want to graph the feasible region. So what I'm going to do is I'm going to go over to my whiteboard. And so I've got my 2 equations. Let me write them here. It was (3x), let me flip back over here, 3x plus 4y is less than or equal to 21. Not sure why that's zoomed in. Let me try to zoom out. And then the next one was 2x plus y is less than or equal to 12. So 2x plus y is less than or equal to 12. Okay. So starting with this one, what I'm going to do is these are inequalities, and in order to graph them, we have to graph the boundary line. So the boundary line is the same as if we had an equal sign there. So I'm going to solve this for y. by first subtracting 3x from both sides. And then I will divide everything by 4. And I get y equals negative 3 over 4x plus 21 over 4. Now this makes it a little bit harder to graph. So we want to plug in values here. What we could do when we have our y-intercept that is not on a grid mark, what we could do is instead pick some x values and then get a y answer. So let's see. If I pick 1 for x, that'll be negative 3 over 4 times 1 plus 21 over 4. And that gives me 18 over 4. Well, that doesn't give me a nice number, so let's choose a different value here. Let's see. What if we pick negative 1? So I'll get 3 over 4 plus 21 over 4. Well, that gives me 24 over 4, which is 6, so that's a good one. So, and all I need is 2 points, so let me try picking another one. Let's see if I pick, I want to pick numbers that when I add them together will give me answers that are divisible by 4. So let's see, 20, let's see if I pick 3. So I'm going to erase this. I'm plugging in 3 here. I'll get negative 9. And negative 9 plus 21, that gives me 12 over 4, which gives me 3. So I have some points there, and I'm going to go to Connect Math, and I'm going to try graphing. So let's pick, we've got plot a point, so I'm going to choose that, and that was negative 1 and then 6. So now I'm going to hit plot point. Did that plot it? Yes. And then I'm going to hit 3 and 3. And then I'm going to draw a line between those points. So I have to exit out of plot the point. And sometimes Connect Math can be really picky, and so leaving those plotted points, it might mark it wrong, but let's just leave it and see what it does. Alright, so I've got the one graphed. Now I'm going to go and I'm going to graph the other one. So the other one, let's go back to my whiteboard. And it was 2x plus y is less than or equal to 12. So again, I need to graph the boundary line, and we have to go back and shade that too. So So 2x plus y equals 12. And then I'm going to say y is equal to, I'm going to solve for y by subtracting 2x from both sides. So now this is kind of off my, if I did the 12, I could plot the y-intercept. The y-intercept is 12, the slope is negative 2. So I could do it like that. But 12, I believe, is off of the grid, so let's see what it looks like here. So, well, 12 is right at the top. So I guess we can't plot that point, but we know that if we go down to and over 1, that would be another point, and then down to and over 1, that would be another point. So now I've got this, and I've got my, I have to do, those are both less than or equal to, so I have to shade below them. Now, let me erase this. We also had, and I'm going to erase this too because I forgot, we also had the two lines that x was greater than or equal to 0, so we've got a line there, and we've got y is greater than or equal to 0, so we've got a line there. So the only region that I'm shading is where it all would work. So this is the only place that it would all work. So now let me hit check answer and see, and it gave me a green check mark. So if you can't graph it using the y-intercept, the other way to do it is to plot, to pick x and y values and then plot them. Part 5, it says, is the point 4,1 in the feasible region, and what does the point 4,1 represent in the context of this problem? So where's 4,1? 4,1 is here. So 4 is the x value, and 1 is the y value. It is in the, yes, the point is in the feasible region. The 4 is the x value. That represents the model A-DES. 1 is the y value, and it represents the B-DES. Producing this combination of DES would exceed the number. No, it would not. It would not, because it would be that feasible region represents the less than or equal to 21. So I would say no here, or would not. So let me hit check answer. I got that right. And then what about the 0.53? Let's go here. Where's 5,3? 5,3 is outside the feasible region. So I would say no, and then I would say it is not. And then 5 is for model A, 3 is for model B, and then it would exceed. If it's outside the feasible region, then it's going to exceed the available hours. So let's hit check answer and check. All right, so that's how to do this problem.